Hello everyone. In this video, we'll start discussing about Gauss' give the mathematical form of Gauss' and prove the statement of Gauss'. As per Gauss' the electric flux crossing any closed surface must be equal to the total charge enclosed by that surface. That is, the electric flux psi must be equal to the charge enclosed Q. For a closed surface as shown in this figure, if the charge enclosed is Q, then the flux leaving the closed surface must be equal to this charge Q. Let us consider an incremental surface on this closed surface, and d suffix s is the electric flux on this surface. So the estimation of electric flux density is on the surface. So the suffix s indicates the flux density on the surface. At any point P, if this incremental surface and ds makes an angle of theta, we consider ds dot del s in terms of this angle theta. If we consider this incremental surface del s, the incremental flux del psi crossing this surface can be given by using the flux density and area element. That is, flux density multiplied with the area gives the flux crossing that del s. We can write ds vector dot del s vector equals del psi. If we want to estimate the total flux crossing this closed surface, we have to integrate this d dot del s over the closed surface, giving double integration over the closed surface, which has a circle with double integral indicating integration over a closed surface. Now, as per the statement of Gauss' law, this integration must be equal to the charge enclosed. This is the mathematical form of Gauss' law. The charge enclosed can be a point charge or n number of point charges or line charge or surface charge or volume charge. If the charge enclosed is several point charges, then it can be taken as summation of charge due to individual point charges. Or if it is a line charge, total charge can be found by estimating integration of the line charge density over the entire line. Or if it is a surface charge, we can estimate the charge enclosed as surface integration of surface charge density. Or if it is a volume charge, we can integrate the volume charge density over the entire volume to give the total charge enclosed. We know for a closed surface, there is a definite volume enclosed. So in general, this charge enclosed can be given in terms of volume integration of volume charge density. Thereby, the psi is equal to closed surface integration of d over the surface, which is equal to the charge enclosed, which is volume integration of volume charge density. We can now prove this mathematical form of Gauss' law by taking a known value of flux density due to a specific charge distribution, performing the integration of integrand, which is dot product of d and ds. Thereby, we have to get the value is equal to the total charge enclosed. Thus, we can prove this mathematical form of Gauss' law. We can start the discussion by taking a point charge Q in spherical system of coordinates, where the charge Q is said to be located at the origin of the spherical system. And the sphere, or when we consider a sphere of radius A around this charge, that forms the closed surface for estimating Gauss' law. We call that closed surface for estimation of Gauss' law as Gaussian surface. In this case of point charge, the Gaussian surface is a spherical surface of radius A. We know the electric flux density produced by a point charge is Q by 4 pi r square in the direction of AR. At a radius of A, we can replace R by A. And the area element over this incremental surface with a constant radius and variable theta and phi can be given as r square sine theta d theta d phi AR cap. At a radius of A, we can replace R as A for this area element also. Then we can estimate the integrand, which is dot product of vector D and the surface vector, which gives multiplication of these two magnitudes, which is Q by 4 pi sine theta d phi where theta has to be integrated over the entire sphere, which is 0 to pi, and phi has to be integrated over the entire sphere, which is 0 to 2 pi. Integration of that integrand with the variable theta and phi gives the evaluation of d dot ds over the closed surface. Integration of sine theta will give minus cos theta, and applying the corresponding limit for theta. And integration of d phi is phi with the proper limits of phi will get the value of d dot ds integration over closed surface is equal to charge q, which is proving the statement of Gauss law. Thank you for watching the video.